Right, so let's take a look at the probability distribution of this. So we've got a game where you're going to flip a coin, roll a fair die, and spin a 5-colored spinner with equal likelihood of any one of the 5 colors coming up. Now you win if the coin flip is heads and the die results in a 4, 5, or a 6, and the spinner lands on any color but green. All 3 events must occur or you lose. So now, for the probability of heads, now if we're going to consider what you need to, what the probability of having 3 favorable outcomes and winning is, well, the probability of heads is 1/2 times the probability of rolling a 4, 5, or 6, which is going to be 1/2, times the probability that it is not green is going to be 4 out of 5. And so this is going to be then 4 over 20, which is equal to 1/5 or 20%. So you got a 20% chance of winning at this game. Now, there's 3 ways that you could have 2 favorable outcomes, and we're going to look at this because in a second we're going to look at the simulation. Obviously you have an 80% chance of losing, but there's different ways you could lose. You could either get 1 unfavorable event, 2 unfavorable events, or you lose on all 3 events. So when we go into the simulation, we're going to see that how this works out. So the probability of tails is the same as probability of heads, which is 1/2. Probability of a 4, 5, or 6 is, again, 1/2, times the probability of not being green is 4/5. So again, this is going to be 20%. But we could also have a 2 favorable outcomes where we get the heads, but we don't get 4, 5, or 6, and we get any color but green. So the probability of heads is 1/2 times the probability of 1, 2, or 3 is 1/2 times the probability of it not being green is going to be, again, 4/5. So this is 20%. Now, for 2 favorable outcomes, probability of heads is 1/2, so we get that right. Probability of 4, 5, or 6, we get that right, so it's 1/2. And then we spin the spinner and get green. Well, the probability of that is 1/5. So that is equal to then 1 out of 20, which is equal to 5%. Now, for 1 favorable event, you could get the coin toss right and then get the other 2 as unfavorable. So this is 1/2 times 1/2 times probability of green is going to be 1/5. So that's, again, 5%. Probability of 1 favorable outcome where you get the coin toss right but the other 2 wrong, it's going to be 1/2 times 1/2 times probability of green is 1/5. So again, this is 5%. The probability of 1 favorable outcome where you get the tails wrong, which is 1/2, you get the coin toss wrong, which is 1/2, times probability of not being green, which is 4 over 5. So then again, this is going to be 20%. And so the number of 0 favorable outcomes, probability of tails, 1/2, probability of 1, 2, or 3, 1/2, times the probability of green, which is 1/5. So then again, this is going to be 5%. And you'll notice then here, if we take a look at the percentage of favorable outcomes, well, 3 favorable outcomes is 20% probability. 2 favorable outcomes will be then the 20% plus 20% plus 5%, which is 45% probability of getting 2 of the 3 right. Probability of getting 1 favorable outcome is going to be 5 plus 5 plus 20, so that's going to be 30%. And the probability of 0 favorable outcomes is going to be 5%. And so when we go into our simulation, you're going to see that the simulation is going to reflect these theoretical results. All right, so I've made up some headings here for my random generator, my simulation for this. So we're going to flip a coin, and if it comes up as heads, we're going to say that's 0, and if it comes up as tails, that's going to be 1. So we're going to use the random number generator, so equals rand between. Bottom number is going to be 0, top number is going to be 1. And for the coin result, I'm going to say equals, and I'm going to use my COUNTIF function. And it's going to be this cell, B3, is equal to 0. All right, and so we'll see if this is working. I'm going to copy this down a few cells, and wherever we see a 0 for the coin toss, we get a 1 in the coin result. So now we want to, again, generate a random number between 1 and 6 for rolling a die. So this is going to be equals rand between. Bottom number is going to be 1. Top number is going to be 6. So now what I can do is this is going to be equals, and I'm going to use my COUNTIF function again. And this number, D3, now my criteria is going to be, I'm going to say greater than 3, which would be 4, 5, or 6, will be a successful outcome. And if you remember, if you roll a 4, 5, or 6, then you win. So I'm going to use my greater than arrow, greater than sign, and 3, and close it with quotations. And see, if you roll a 3, you get 0, which signifies you didn't win. And I'm going to copy this down to make sure my formula is working. So here where I get a 6, I get a result, a die result of 1. When I roll 1, 2, I get a die result of 0, and 5 is a die result of 1. So now for the spinner, we got 5 outcomes. So I'm going to say equals rand between, and the bottom number will be 1, and the top number will be 5. And recall, if you spin a green, then you lose, and if you spin any other color, then you win. So for the spinner result, I'm going to say equals COUNTIF cell F3, and again, is greater than 1. Greater than 1. And copy this down to make sure it's working. So wherever we see a 1, we should see a spinner result of 0. And so you can see right here, the last one, spinner result of 1 results in spinner result of 0. So now what I'm going to do is see if we have 3 favorable outcomes, then our sum is going to be 3. So this is going to be equals, and it'll be the coin result plus the die result plus the spinner result. And see, we end up with 2. And I copy this down, and you'll see that in these number of trials, I did about 10 here, 9 or 10, and I got no, I didn't win once. Now, I'm going to format this as a table. So I'm going to copy this down to cell 1003. Sorry, 1002, I think will give me 1,000 results. And I'm going to format this as a table. And so this is going to be equals COUNTIF, and here's our range, is going to be our sum, and our criteria is going to be quotation mark equals 3, close quotation mark again, press return, and we get a value of 196. So if we've done 1,000 trials, 20% would be 200, so we're not far off that. And so I'm going to copy this down, and you'll notice it changes every time. But now I'm going to change the sum of 3 to 2, which means that we had 2 favorable outcomes. And we get 449, and remember, I believe it was 45% was the number of favorable outcomes for two favorable outcomes. It was a 45% chance. So then equals, let me copy that down again. And change these to 1 and to 0. And remember, 0 was 5%, so we expect a number somewhere around 50 for number of favorable outcomes, and we got 51. So here, I'm just going to double check to make sure that I've got 1,000. And there's 1,000 trials. So what happens now is we can figure out there's a 20% chance of someone having 3 favorable outcomes. So now if we're going to say that the payout is going to be $3, let's say. So it's going to be 3 times the number of favorable outcomes, and that's going to be divided by 1,000. And so we get an expected value of 0.606. In other words, if you're paying out $3 every time someone wins at this game, then let's say someone plays 100 times, you would expect them to win 20% of the time, which would be 20 times, and for every time they win, they would get $3. So that you would expect that they would bet $100 and you would then pay out $60. And so that is our expected value is 0.6, which means that you expect to make, or the person expects to win a little over 60 cents, according to this, even though it's really actually 60 cents when they play each of these games. So the expected payout for this is 0.6, but the actual payout was a little bit more. And you'll notice that if I type the number in here, well, here the expected payout was the actual payout was a little bit lower than the 60 cents. Right, so now what I'm going to do is I'm going to change this spinner to a card draw. So I'm going to say, and I'm going to make the odds really, really low as far as what we can do. And so the card result, I'm going to say if you draw a 2, then you win. So you have to flip ahead, roll a 4, 5, or 6, and draw a 2, and then you're going to win. Now, okay, and so there we go. And so now for it's got to be, we're going to say drawing a 2 will be a 1, a 2, a 3, or a 4. So I've got to have this greater than 4. And so most of the time, you draw a card greater than 4, other than a 2. And if we look at the theoretical probability of this, so we know that the probability of flipping ahead is 50% times 0.5 times, and so now we're going to do, it's 1/13 or 4 divided by 52. So it's a little less than 2% chance of actually doing this. So flipping ahead, rolling a 4, 5, or 6, and drawing a 2 is about 2%. And so now the number of favorable here, is quite a bit because I've done this wrong. I have to say is less than 5. And so most of the time, you can see we have a 3, so that's a 1. Any other ones in here? A 1 is a 1. So that means that we now have reduced our number of favorable outcomes. And you'll see that we have quite a few 2 favorable outcomes, even more 1 favorable outcome, and 0 favorable outcome is quite high. And you'll notice that our expected payout is only 8 cents. And that's because remember we had this as $3. So what I'm going to do is I'm going to change this to 40. So it's a $40 payout. And now we're moving into closer to what we expect. And so if I type another number in here, there we've got an expected payout. Now, so $40, let's take a look. So it was about 0.019%, 192 or something like that, times $40. Comes out to be an expected value of 76.8 cents. Now, this is a little bit off. But now, because this seems to be a little bit more variable this time than the last one, if you get 23 favorable outcomes, well, then you're paying out 92 cents. And so you're going to break even as long as you don't pay out more than 25 times in 1,000 trials.